Lesson 2, I will solve multiplicative comparison word problems by applying the area and perimeter formulas. So in Lesson 1, we talked about how you find the area of a rectangle and how you find the perimeter of a rectangle. Well, we're going to be solving some word problems, and these are multiplicative comparison. That means that we will be comparing two rectangles using multiplicative terms, like saying this rectangle is 2 times as large as this rectangle. That's how you use the multiplicative comparison. All right, so let's go ahead and write our name on our problem set, and then let's take a look at the directions. So a rectangular porch is 4 feet wide. It is 3 times as long as it is wide. Label the diagram with the dimensions of the porch. Well, it tells us that it is 4 feet wide, and it's 3 times as long as it is wide. So this must be the width. And you can see that it's 3 times as long as it's wide. You can see they actually have 1, 2, 3 of these. So we have 4 feet 3 times. This is the multiplicative comparison. 3 times as long as it is wide. When you're using the word times to compare, that's a multiplicative comparison. All right, so we label the diagram. Now we're ready to find the perimeter of the porch. So remember, to find the perimeter, the formula that we discussed yesterday was length plus width plus length plus width. Well, if I take all of these 4, 4, and 4s together, what's that going to give me? What's 4 plus 4 plus 4? Well, 4 plus 4 is 8, plus 4 more would make 12. So we have a length of 12 feet, a width of 4 feet, and then we have the same thing again. Well, the way I like to do this is, since this is obviously the same problem twice, I like to say, well, 12 plus 4 is 16. So 16 plus, and this is going to be 16 also, equals 32 feet. So the perimeter of the porch is 32 feet. Now we have a rectangular banner, which is 5 inches wide. It is 6 times as long as it is wide. So we're going to draw a diagram of the banner and label its dimensions. So let's start with a tape diagram here. And I'm going to make it kind of long because it said it's 6 times as long. Plus, banners are really long and narrow. Like if you think about a happy birthday banner, they're really long and skinny. So we know that this is going to be 5 inches, and then we know that it's 6 times. So I'm going to divide this tape diagram into 6 parts. I'm going to divide it in half, and I'm going to divide each half into thirds like this. Now that's going to give me 1, 2, 3, 4, 5, 6. 6 times as long. So each of these have a dimension of 5 inches. Okay, so we drew the diagram and we labeled its dimensions. So that's all it's asking us to do in A. In part B, it wants us to find the perimeter and the area. So let's start with the perimeter. So remember, perimeter is going to be length plus width plus length plus width. So let's find the total here. I can count by 5s, right? 5, 10, 15, 20, 25, 30. So that tells me that this whole side is equal to 30 inches. So if this side's 30 inches, then this side must be 30 inches, and this side's going to be the same as the opposite over here, which is 5 inches. So I've got a perimeter of 30 inches plus 5 inches plus 30 inches plus 5 inches again. Now again, I'm going to go ahead and add these two together because 30 plus 5 is 35. You can do it any way you want to. I'm going to say 30 plus 5 plus 30 plus 5, which is 35 plus 35. Well, I know 3 10s plus 3 10s equals 6 10s, and 5 1s plus 5 1s equals another 10. So I've got 6 10s plus 1 10, which equals 7 10s, which equals 70 inches. You could have done that any way you wanted to. It may have been easier for you to say 30 plus 30 is 60 and 5 plus 5 is 10. That's up to you. Now I'm going to draw a little line here to divide my perimeter from my area. Now if you remember, the formula for area was length times width. All right, so we know that the length is 30 and we know that the width is 5. And these are inches. Now, you might think, well, I can't do 30 times 5. Well, yes, you can, because you can think of this as 3 tens. 3 tens times 5 would be equal to 15 tens, which is the same thing as 150 inches. Okay, so we have a perimeter of 70 inches and an area of 150 inches. Okay? You're going to do some by yourself, so I hope that you're paying attention. All right, now let's take a look at number 3. The area of a rectangle is 42 square centimeters. Its length is 7 centimeters. So first of all, we're going to approach this with an RDWW approach. We just read it, now we're going to draw. So we're going to start with our tape diagram or our rectangle. And we know that the area is 42 square centimeters. So I'm going to write in the middle 42 square centimeters. So that's my area. And I know that the length is 7 centimeters. And I'm trying to figure out X or B or whatever you want to call it. You can, in this case, maybe it might be better to call it width since we're already using a multiplication symbol. So remember that to find the area, it is length times width. Well, we know that the area is 42 square centimeters, and we know that the length is 7 centimeters, so we're trying to figure out what is W. Well, what times 7 is going to equal 42? This is where it really helps to know your multiplication facts. Okay, you could always count by sevens, and you could say 7, 14, 21, 28, 35, 42. And then you could go back and count how many sevens that is. 1, 2, 3, 4, 5, 6. So that means that 7 times 6 equals 42. Therefore, the width must be equal to 6 centimeters. So I'm going to answer that with a word statement, and I'm just going to say the width is 6 centimeters. But if you knew 7 times 6 was 42, that would save you some time, right? Now it says Charlie wants to draw a second rectangle that's the same length, but is 3 times as wide. Draw and label Charlie's second rectangle. All right, so we've got another rectangle like Charlie's, okay? Now I'm going to draw this one a little bit smaller, and I know that this is the way that Charlie's rectangle looks up here. I'm going to do this a little bit different just for space more than anything. So this is not an accurate drawing, okay? But we know that the length of Charlie's rectangle was 7. So I'm going to put 7 here, even though I know up here 7 was at the top. And I'm going to use 6 as the width. The reason why I'm doing that is because it's 3 times as wide. And it's just easier for me to go 3 times this way than it is for me to go 3 times down. All right, so we're going to go 3 times. That's not exactly the same, but we're going to pretend that it is. So we know that Charlie has a length of 7, and then he has this width 3 times. Okay, so it just said to draw and label Charlie's second rectangle. So that's what we did. So here we have the length is 7, and we have the width is 3 times as wide as it was in his original rectangle. All right, now we're going to come down and look at our next question here. It wants us to find the perimeter of Charlie's second rectangle. I'd like for you to try to find the perimeter of this rectangle all by yourself. If you're still having a little bit of trouble using that perimeter formula and you want to stay with me and do it with me, that's fine. But I'd like for you to try to pause the video and do it by yourself. Okay, so hopefully you try to find the perimeter by yourself. Now remember that the perimeter is length plus width plus length plus width. So I knew that the length was 7, and then I had to figure out the width. So I knew that 6 plus 6 was 12, plus 6 more was 18. So that gave me 7 plus 18 plus 7 plus 18. So 7 plus 18 is equal to 25. So I had 25 plus 25, which was equal to 50 centimeters. And then altogether, or to to write my answer as a statement, I wrote the perimeter is 50 centimeters. So hopefully you're starting to become a little bit more comfortable with the formulas for area and perimeter. All right, now let's take a look at our very last question. We have question number 4. All right, so the area of Betsy's rectangular sandbox is 20 square feet. The longer side measures 5 feet. The sandbox at the park is twice as long and twice as wide as Betsy's. So at first read through, I'm thinking this sounds a little bit confusing. So I just read it. I'm going to go ahead and read it again before I start drawing. So let's see. So we have a sandbox that has an area of 20 square feet. Okay, so I'm going to go ahead and draw a rectangle because it says that it's rectangular. And I know that the area is 20 square feet. And it says here that the longer side measures 5 feet. Okay, so it says draw and label a diagram of Betsy's sandbox. What's the perimeter? Now it talks about the sandbox of the park up here, but I'm not going to deal with that yet. I'm going to take care of question A because it doesn't talk about the park. It just talks about Betsy's sandbox. So over here, I don't know what the width is. I know that the area is 20 square feet, and I know that the formula for area is length times width. So that tells me that 5 feet times whatever W is going to tell me what must equal 20. So that's going to help me to figure out what 20 or what W is. So I'm thinking to myself, I could count by 5s, right? I could say 5, 10, 15, 20. So how many 5s is that? That's 4. So that means that 5 times 4 is 20. Therefore, W must equal 4 feet. But it doesn't ask what is the width. It asks what is the perimeter. So now I've got to find the perimeter. So remember, perimeter is length plus width plus length plus width. I'd like for you to pause the video and see if you can't figure out the perimeter of Betsy's sandbox all by yourself. Okay, so I knew that the perimeter was length plus width plus length plus width. And I knew that the length was 5 and that the width was 4. So whenever I was writing my number sentence, I wrote 5 plus 4 plus 5 plus 4. When I added that together, 5 plus 4 is equal to 9. So I had 9 plus 9, which equals 18. So I wrote the perimeter is 18 feet. And notice I tried to keep my word sentence over here because I didn't want to take up any room that I was going to be using to answer B. So I kind of try to keep it over here in this area, okay? All right, so let's take a look here at part B. And it says draw and label a diagram of the sandbox at the park. So now I'm going to go back up here and I'm going to reread this part that they told me about the sandbox at the park. It says the sandbox at the park is twice as long and twice as wide as Betsy's. All right, so here's Betsy's. We just figured this out and we know that Betsy's has a length of 5 feet and a width of 4 feet. It says here that it's twice as long, so I'm going to make it twice as long. So that's going to make it 5 feet that way, but it's also twice as wide. So it's going to be 4 feet this way. So does that make sense? It's twice as wide and twice as long. So we had to double both of them. All right, so now it says, what is the perimeter? So again, we're going to find the perimeter. The perimeter equals length plus width plus length plus width. I'd like for you to go ahead and find the perimeter of the sandbox at the park all by yourself. Okay, so hopefully you pause the video and you're not just copying everything that I do, because whenever you're doing that, you're not really learning, you're just copying. All right, so I went ahead and filled in all of our variables. I knew that the length was 10 because I added 5 plus 5, and I knew that the width was 8 because I added 4 plus 4. So I have 10 plus 8 plus 10 plus 8. So that gave me 18 plus 18, which was equal to 36. So the perimeter of the sandbox at the park is 36 feet. Now it says, what is the relationship between the two perimeters? So I have 18 feet, and I have 36 feet. So I want you to take a minute just to think about, what do you know about 18 and 36? Okay, well, what kind of ideas did you come up with about the relationship between these two numbers? Obviously, this is bigger than 18, yes, but it's more than that. I hope that you were able to say that 30, or to come up with 36 feet is twice as large as 18 feet. Because that's the truth. 18 plus 18 equals 36. So we double the length, we double the width, and our perimeter doubled. Interesting. All right, so now we're going to find the area of the park sandbox using the formula length times width. So now remember that the park sandbox, let's think about the dimensions that we have. We have area equals length times width, and we know that the park sandbox was 8. So remember that we had a length of 8, a length of 8 and a width of 10. Okay, so I want you to think about what would be 8 tens, or what is 8 times 10? Well, that would be 80, right? So when we do area, we use square feet. So the area of the park sandbox is 80 square feet. Now it says the sandbox at the park has an area that is how many times that of Betsy's sandbox. So remember that Betsy's sandbox had an area of 20 square feet, and the park sandbox had an area of 80 square feet. So it's wanting to know how many times more is 80 than 20. So think about that. Let's count by 20s. 20, 40, 60, 80. So that means that 20 times 1, 2, 3, 4 is equal to 80. So how many times larger is 80 than 20? So it's 4 times larger. So that means that the area of the park sandbox is 4 times larger than Betsy's. Excuse my handwriting, it doesn't look so good today. All right, last question. Compare how the perimeter changed with how the area changed between the two sandboxes. Explain what you noticed using words, pictures, or numbers. So when we looked back at how the perimeter changed, remember the perimeter was twice as large, but the area was actually 4 times larger. So what do you notice? I'm going to type this because I think I can type a little bit faster here than I can write, since my writing's not looking quite so good today. All right, so let's say the perimeter was twice as large, but the area was 4 times as large. And think about, what did we do to the sandbox? We actually doubled the length and double the width, and that just doubled the perimeter, made it twice as large. But it made the area 4 times as large, which kind of makes sense if you think about our diagram, because our diagram looked like 4 of Betsy's sandbox. When we doubled the area and we doubled the perimeter, it made it look like there were 4 of her sandboxes. So that made the area 4 times as large. All right, so this was using the multiplicative comparison using area and perimeter formulas.